Welcome, everyone. My name is Sean Falconer, and this is No Time for the Dad Bod, Automating Life with AI and Databricks. How many people here are parents? A good amount. So when I put this talk together, I had all of you in mind, but even if you're not a parent, I think we could all use and benefit essentially by having more time available to us, and that's really what this talk is about. So about 15 years ago, I left the sort of comfort of academics. I was doing a postdoc to become the CTO and founder of a startup. And I remember thinking vividly at that time that when I moved into the real world, I was like, this is the real world, this is real work. I now know what it means to be busy because I'm doing things in the real world. It's no longer this academic sort of highfalutin type of stuff where I have lots of free time. And then fast forward to today, and now I realize that I was extremely naive because now I have two of the most demanding bosses that you'll ever have. And I'm not talking about Jay Krebs, the CEO and founder of Confluent. I'm talking about toddlers. They are very, very demanding, and they don't really care what your day looks like because essentially the only thing in their mind is their priorities and what they want. They're slowly sucking the life out of me. They're very cute. I love them very much, but they're killing me at the same time. My day started at 4:30 a.m. today because that was when my daughter woke up screaming this morning. So every day feels like a sprint. It's like go, go, go until I basically pass out on the couch at the end of the day. So I remember the luxurious days when I was the CTO and founder of a company, and I really only had to care about myself and my business. So as we get older and we take on more and more responsibility, whether that is as a parent or our careers or some combination, it becomes harder and harder essentially find time for things like our health and fitness and prioritize things that maybe are personal to us. We end up essentially often prioritizing our kids and our careers over our own personal health, our own personal fitness, which makes a ton of sense, but essentially, hence we end up in a situation where we end up with the dad bod. So I wanted to figure out how could I essentially help myself balance this equation, because this becomes very unsustainable, where you're putting so much time into your family, so much time into your career, inevitably you have to give up something. However, over the last couple years, we've had a tremendous amount of success using AI in the workplace to basically increase employee efficiency. People are able to, depending on your job, increase your efficiency by maybe 2, 3, 4, or 5 times X at times for different types of work. So what I wanted to do was figure out not only how can I be a more efficient employee, but how can I be a more efficient dad, and how can I be a more efficient husband, essentially, and use some of these techniques that we're finding success in the workplace with my home life. So that's really what this talk is about, is how can we use AI to essentially make our family life more efficient. And all this stuff started pretty innocent for me. Initially, it started with just prompting, essentially using ChatGPT. So my kids go to preschool, and every week they have to bring a show and tell item based on the letter of the week. And my son's been going there for like 2.5 years now. And when you're on the 14th time of trying to figure out a show and tell item for the letter Q and it's 6 in the morning, sometimes I need a little help. So I started using essentially ChatGPT as an extension of my dad brain to help me brainstorm these types of things. And it works really, really well for this kind of stuff. So I started leveraging this all the time. And then additionally, I started using it as a way, things like Dolly, as a way to help my son explore his own imagination. He thinks that when he grows up, and maybe this will happen, but he wants to be a superhero when he grows up. That's the job he wants. And in his mind, he wants to be the superhero named Rainbow Racer, and that can shoot trains out of his arms, apparently. And essentially, we used Dolly, and I helped him craft the prompt to essentially create the image of what was in his head. And then we went from there to start taking essentially his ideas and creating his bedtime stories, where we can create these highly personal, dynamic stories for him where he's the protagonist and the hero, and they're based on his ideas. And it's a great way, one, to encourage him to go to bed so I can have more time at the end of the day, and make him excited about reading and storytelling, crafting the story, and kind of learn how to prompt AI. So that's where these things started. But of course, I wanted to take it up a notch. I wanted to essentially offload more and more sort of responsibilities that become a hindrance in my home life so I could carve out more space and time to prioritize things like making the right food choices and exercising and things like that. So that really leads us to agents. So agents, I'm sure there's a million talks about agents. Agents is all the rage right now. Agents are the new app. SaaS is dead. It's all about agents. And agents are very, very exciting from the idea that we can offload these large asynchronous chunks of work where historically maybe a person was or multiple people were involved in that process. So I wanted to figure out how can I leverage agents in my home life to automate some of this stuff. On top of that, I've been working in the intersection of data, AI, knowledge engineering for my entire career, originally as an academic, even doing my company really, really early sort of conversational AI systems. So I've been building in production sort of enterprise-grade AI for a long time. And even though these products that I was building for my home life, I'm probably going to be the only user. They're basically be fine if they were demoware. I wanted to take things that I talk to customers at Confluent every day about and what are the right technologies that you need to actually build this stuff in production systems and apply that to these essentially projects I was building on my own so I could use those as a way to demonstrate some of these ideas I talk to customers about. So, because actually building agents, as exciting as they all are, is actually really, really complicated. You know, a single agent has a tremendous amount of potential dependencies, where you have data systems that you're relying on, tools, you have a stochastic model that's making decisions on your behalf, you have feedback loops, anything that's in production, you're gonna have a certain amount of observability, you want logging, tracing, all these sort of things that you do with any sort of piece of software that you're putting in production that's user-facing. And really, you end up with a large distributed system problem. And realistically, people aren't gonna build a singular monolithic agent to solve all problems. What they're going to do is essentially decompose a problem into smaller sub-problems, where these smaller sub-problems are essentially encoded into purpose-built agents, and you have a multi-agent system where you have multiple agents working together to solve a complex problem. Just like we have multiple people in the workplace work together as a team to solve complex problems. And as these systems scale and you add more and more agents and more tools and more data, you essentially end up with this very complex labyrinth of interdependencies and a quadratic explosion of dependencies. And this becomes very difficult to scale in a request-response, point-to-point approach, where you're just making essentially API calls between each of these, because if one of these agents decides to hallucinate or produce an output that's not what you're expecting, the whole thing is gonna end up in a really, really bad situation. Now, luckily, we have seen similar problems in the past. So if we go back, essentially, back to the era of when we broke up the monolith, some people are still doing that, but like 15 years ago, we realized that essentially a monolith becomes a barrier to scale because you have to continually scale the resources available on the server. So people split up the monolith essentially into microservices. And that way you could decompose it, you could have different teams work on different parts of it, and you can scale the resources for each of the microservices independently. However, you end up with a similar set of quadratic explosion of dependencies if you're using essentially a request response model for this. So now microservice A that's sending data to microservice D needs to know a lot about the resources available in D, otherwise it could potentially overload it, send too much data to it, take it down, and take the entire graph down. So the way that people solved this problem was through event-driven architecture, where instead of having a quadratic number of dependencies, we end up with a linear number of dependencies where everything's loosely coupled, all microservices essentially just producing, consuming events, and we have an event broker essentially responsible for durably delivering those messages on each side. And this way, we can have multiple consumers. Microservice A doesn't really need to know anything about downstream consumers. And this is extremely scalable. This is how some of the largest systems in the world, like Netflix and Uber, essentially run with thousands and thousands of these microservices. And really, I think the great gift of the world that technology like Apache Kafka gave us was this decoupling of services, decoupling of teams. And this same architectural pattern that we've been using so successfully for scaling microservices should be essentially the same architectural pattern that we use when we start to think about scaling and deploying multi-agent systems. Because realistically, what is an agent from a deployment standpoint? It's really just a microservice with a brain. It's a microservice that has an LLM that has some additional context. But you're gonna deploy it essentially as a microservice. A multi-agent system is a bunch of microservices that all need to talk to each other. So what we need to be doing essentially is building event-driven multi-agent systems, where agents become just producers and consumers of these events. So you get a loosely coupled system, you can get exactly once delivery of the messages, and there's a lot of other nice properties where you can basically rewind the tape, replay these things, so I can do essentially a dark deployment of an agent, A/B test an agent, test a new version of the agent, all against live traffic without side effects. And when we combine that essentially with something like Mosaic AI, where we have a very robust AI platform for building, deploying, and hosting agents, as well as governing, we can essentially build an extremely robust, durable, fault-tolerant, enterprise-grade multi-agent system. So I wanted to essentially take that idea and apply it to my own life. So I've done this a number of times for a bunch of different projects, but the one we're going to talk about is building a meal planning agent. So every week, it becomes rather stressful at times to figure out what we're going to essentially feed ourselves and our kids. And when you have little kids that go to bed at 7, you don't have a lot of time at the end of the day to figure out what you're going to eat. And if you don't have a plan, what you end up doing is eating a lot of garbage or takeout or cooking separate meals. None of it is a good solution. It becomes stressful, not ideal for trying to find extra time. So it's much better to essentially have a plan in place. So I wanted to solve this problem where I wanted to be able to take essentially our kids' preferences for food, our own preferences for food, any hard requirements like my daughter can't eat fish, number of meals that we need, any recent meals so that I'm not just repeating the same meals over and over again, throw it into this AI magic box and essentially create a weekly meal plan with our recipes and everything like that. That's the goal. So the way that I did this was I decomposed essentially our AI magic box into a bunch of different multi-agents that are purpose-built. So the first one is our child meal planning agent. I'll go into details about what's involved there. Adult meal planning agents responsible for building an adult meal plan. A shared preferences agent, so basically the responsibility is to combine these into a single holistic meal plan. And then finally, an agent that's responsible for taking this blob of text, converting it into an output that we can actually render on a screen. I used a couple of different agentic patterns to support this. So the first one, most of the agents are React agent design pattern, where this is basically a tool calling agent. You go through a thinking loop where it's figuring out which tools to call, performs those tool calls, gets back the additional context, loops until it essentially generates a final response. And then also use the reflection agent for combining the meal plans, where the first agent is generating the combined meal plan, and the second agent essentially judges it and evaluates it, and then you go in a loop until you create something good or you hit the threshold of the loop. So bring this all together, it's a little bit hard to see, but I built a simple front end and back end using Next.js and MongoDB to host this. This is essentially where I store the settings, family preferences, meals, and when a request comes in, I'm going to send that essentially to the database. And I'm using Confluent Cloud's managed Kafka and Flink for inter-agent communication. So this is basically the backbone of that event-driven messaging system for agents. And then I'm using Mosaic AI for the agent and model hosting. So when a request comes in, essentially I use a managed connector to bring that data, that request from MongoDB automatically into a Kafka topic called a meal plan request. And then from there, I'm syncing that through a managed connector down into this microservice, which is the child meal planning agent. And essentially, this agent has a specific role where it's an expert in designing nutritious meals that toddlers love, and there's a bunch of other specifications here. So that's its job. And it has a bunch of access to tools like kids' preferences, hard requirements, recent meals. So it's going to use those dynamically and essentially create a meal plan that fits all this profile. There's also a bias towards meals that you can prepare in like under 20 minutes. And then in parallel, completely decoupled from the child meal planning agent, I also run the adult meal planning agent, where its role essentially is to be an expert in designing high protein, low glycemic, low carb dinners for couples so that we can make good, healthy meal choices during the week. It also has access to tools like recent meals. Both of those agents spit out their output to another Kafka topic, the adult child meal plan. And then I use Apache Flink to write a Flink job to combine those streams. So this Flink job is essentially running continuously, joining those two streams. It doesn't matter when they arrive. Essentially, I'm just joining on the request ID. Pretty simple stuff. Once we have that combined meal plan, I send it over to the shared meal plan agent, which is using this reflection pattern. And there, essentially, there's one agent that's going to generate response. The other agent is essentially evaluating and grading the quality of the recommended meals on taste, variety, and nutritional value. So the goal is essentially just keep looping until you create something that's actually good and fits all the specifications I have. And then that writes the output to the complete meal plan. I sync that down to the output, the format output agent. The format output agent is just gonna take this blob of text, essentially split it up into the ingredients list, the meal plans for the week, the shopping list, and so forth. And then I send that all back to MongoDB where I can surface it on the front end. So what this looks like essentially is something like this, where I get the meal plan for the week, all the meals, the adult-child versions, and the ingredients, and then there's also a recipe list, as well as the instructions for actually cooking this. And we've been using this for about 6 or 7 months now. With this, we were essentially able to take something that was often like a chaotic situation, led to bad choices, cost us a lot of money because you're substituting essentially DoorDash delivery for food, sometimes in a scramble rather than having a plan. And I was able to do it essentially using these sort of production enterprise-grade techniques where we're using event-driven architecture to address things like state persistence, durable execution, coordination, replayability, all really, really important for building multi-agent systems in the enterprise. And then Mosaic AI and testing, tracing, model, and agent serving. Is this overkill for a single user meal planning agent? Absolutely, it is absolutely overkill. But it really shows and demonstrates what it is. There's a combination of technology that you really need to bring to bear to actually put this stuff into production. And I would say 99% of actually building successful multi-agent systems is about practical computer science, software engineering that many of us in this room have been doing for most of your career. And it only has a small percentage to do with actually the AI models, because building on top of AI models is much different than building models itself. Well, there we go. I think we have a few minutes for any questions if we have it.